Welcome in session 91E, back from Small and Mobile Studio 11, where we tackle a third example with regard to transforming a classical iterative algorithm to a recursive iterative algorithm. And this time we're going to look at what is a palindrome. So we're gonna set up the algorithm that finds out whether a sequence of characters that we call a string is a palindrome or not. Of course, firstly we have to know what a palindrome is, and I went to the first knowledge resource, Wikipedia base, and there, a couple of days ago, in any case, I could read the following. A palindrome is a word, number, phrase, or other sequence of characters which reads the same backward as forward. I'm already glad that they broadened the definition from a word, because what is a word? Well, a word is actually, the definition of a word is something that you can find in the dictionary and that has a meaning. And that is certainly not the case when we look at what we're going to do with the algorithm that we're going to try to set up and to investigate. So it's more than only words that are recognizable and that have a meaning, but a sequence of characters will also be okay. Some real palindromes that we know. In English, you have then the words madam or race car. Then in French, for instance, the word elle, which means in English she, which is not a palindrome, but this is because you can read it from left to right and from right to left. In Dutch, you have, for instance, the word lepel, which means spoon. So in English, it's not a palindrome, but in Dutch it is. There are also whole sentences that can be palindromes, but okay, you know the principle, and you see here three examples at which we look, and you see that the first and the third one are palindromes in the meaning of how we interpret it, and the second one is not. But I put them here with another meaning, or because of the fact that you can have an even number of characters and an odd number of characters, and that has even some importance with regard to finding out whether it's a palindrome or not. Because what are we going to do? What we're going to do? Well, let's look at the next slide, and maybe we can then find out. We're going to have two counters, a left counter and a right counter. The first will start at the left side, what did you think? And the other one at the right side. And then they will compare, because we can look at a string. For those who don't know that, a string is an array of characters, array of characters. And most modern languages, programming languages, are able to split up a string in all the characters that they consist of. It is even so that in some programming languages, a string is defined as an array of characters, as an array of char. So we can do that. And so we can look at zero-based or not. If we're going to program it in Java, then we are working with a zero-based array. So the first character, the B in this case, is on place on position 0, and so we're going to compare the value, the real value on position 0 with the value at the right side, and then find out if they are the same. If it is so, then we add one to the left counter and we subtract one from the right counter, and then we compare again, and so on. The first time that one character is not the same from left and right side, then we stop the algorithm and we decide that it's not a palindrome. If the left and the right counter encounter each other and even pass each other, well, then we know once they are at the same height that the word or the string that we are looking at is really a palindrome. That's in a nutshell, or not in a nutshell, what we're going to do. Okay, our approach, or what we want to do, is to have the conversion and the transformation from SIA to RIA. That's for us the most important thing. So not spending too much time on considering how to write the algorithm with a classical while loop, which I wrote here. So you can always stop the video and look at it, of course. But what I told you a couple of minutes ago is what is standing there in that classical iterative algorithm, if you can say it. So we take the left position. Yeah, of course, we're going to start with the fact that you have to write in your precondition and so on that the string is really a string and so on. It's not a null value and so on. So those specialities, that's not for us. So in that case, if it's a real normal ordinary string that we have a left position starting at 0, 0 based, then of course we have to take the length -1 to have the writer outside. And then while those positions left is smaller than right, what are we going to do? Well, we're going to compare the left position with the right. If they are the same, then we are not going to this selection, and we're going to deduct one from right position, add one to left position, and go in the while loop again until they are not the same and false is returned, or until left position is not smaller than right position anymore. If that is the case and we're still here, well, then we have to return true because we have a palindrome. Yeah. Now comes, of course, the main part of this session, because what we want to do now. Yeah, some of you could say, yeah, but I don't need this. I don't need this. I'm going to write it right away as a recursive algorithm. That's also something you can do, of course. But if we consider everything that was said in the previous sessions and the roadmap that I proposed to you, well, of course, we're going to start with writing, already directly in Java, or what Java should be. A static method, because I'm working in the neighborhood of the main. I'm calling those methods in the main. So the return value is a Boolean, and we're going to call it is, but I'm going to abbreviate it. So is palindrome sequence and then RIA, dus recursive iterative algorithm. Now I need parameters. I don't have enough place here, so I'm going to write it beyond it, but of course it must come behind it, so watch out for that. Of course, my first parameter will stay the same, and that will be the string under test. The string under test. Then I prepare my other work. I have to designate the loop that I will want to replace, and that is this while. I hope you can see that there is only one loop, so this while will have to disappear. And this is the condition that is standing there. So on top of that, I have two counters, and those two counters I need every time I go through this loop. So those counters change. Well, what I have to do then is actually take those counters. I'm going to call it PL from P left, and the other one is int P right from the other side, because in a recursive iterative algorithm, the parameters must be able to change every time you call the method, otherwise you're going to end up with an endless loop. And now I start. We have two cases. You know that you have a base case where the part is not iterative, and that is when the following is true. Namely, I'm going to write it. Now watch out, if my counter from the right, so P right, I think I used a small p, P right, if P right is smaller or equal than P left, left is this side, that's left, and right is here. But if right is became smaller than the counter left, which means that left is gone to this side and right is gone to the other side, well, then we know, what do we know? Well, we know that the algorithm has checked beyond the half of the string, and we know that it must be a palindrome, and so we return true. And that is also what we see here. That is actually this part. That is actually where we come out of this while loop. So that is the base case, and then we go to the recursive case. Else, what needs to be done now? Well, we're going to write it here. So this is now maybe with a comment sign or something. So the recursive case. And what do we write now? Well, we're going to take the condition that is actually here on this line and write it here also. If, and now we write real Java code. So I'm going to take the right, so it's a charat that gives us the character at the position of, in this case, P left. If it's not equal, this sign for not equal, an exclamation and an equal sign, P, so the string under test charat at the other side, so meaning the right side, yeah, the p right, if that is not the case, so they are not equal, well, then I return false. At that moment, I stop my iteration, my recursive iteration, I return false. In the other case, I'm going to put away those brackets for a while. Else, in the other case, what I'm going to do then? Well, then I'm going to call that same method again, but with changed parameters, yeah? So I'm going to return, yeah, return the is palindrome sequence recursive iteration algorithm with the same, yeah, the same string that stays the same. And then I'm going to say, okay, my p left must be, there must be added one value, and the p right subtracted one value, and I do the method again, yeah. And then I close everything, and I think I'm ready. So this once again is an example of turning a classic iterative algorithm to a recursive iterative algorithm. Maybe you could say, but now I have to add 3 parameters instead of 1. Well, then once again you can use a preamble method. I don't know if I put it down here also. Let's take a look at the next. Yeah, that's this. So what you see here is what I wrote down also in the previous slide. I hope you can compare that. This is hardly readable, but this is the same. Otherwise, stop the video for a while and you will see that this is actually working code. I tested it once again, even a couple of minutes ago, and then this is, this I have to throw away because it's the old version. It's not a good one. But then you have here a kind of preamble, let's say. So if you then use in your code this to call your recursive iteration, then you only have to add the string. The string is the only parameter, and then in the body of this this method, then you call your real recursive method, with then 0 to start from the left, and then the length -1, because 0 based as the outer right character where you start from the other side. And so you can see that you have a recursive iterative algorithm instead of a classical algorithm, classical iterative algorithm. And I think that's all we had to say about that.